What's good, everyone? This is group Murder of Crows. In this group, we have Renee Harden, Joshua Williams, Ahmad Hodge, Eric Davis, and me, Dontavia Stevenson. Now, you might be wondering how a guitar is incorporated with physics, but in this video, we will be showing you 3 major physics principles that can be applied. They are potential energy, kinetic energy, and the frequency of sound. First up, potential energy. Now, what is potential energy? Well, potential energy is basically the stored energy of an object because of its position or configuration. In the first clip, we have the man's hand in position, ready to strum the guitar. When a man's hand is at its highest point, there is the most potential energy. Kinetic energy, on the other hand, is the energy an object has while in motion. When its hand is moved from its starting position, it builds kinetic energy. The further down it goes, the higher the kinetic energy is.
When his hand is at the lowest point, that is where he has the most kinetic energy. Kinetic energy and potential energy are inversely proportional. The more potential energy there is, the less kinetic, and vice versa. Think about the north and the south. The higher north you go, the colder it gets and you will see snow. The more you travel south, the warmer it gets. And when you are finally deep south, it tends to be the hottest and you won't see any snow. Now to the frequency of sound. How about harmonics? What is it? Harmonics is the study of the physical properties and characteristics of musical sound. On this portion, we will be dealing with pitch. The pitch of a note is determined by how rapidly a note vibrates. The thicker or larger the string is, the slower it vibrates. The thinner the string is, the faster it vibrates. How long a string or chord is can also determine the pitch. Higher pitched sounds have more vibrations per second. Lower pitches have less vibrations per second. Now, it's said that middle C usually has an equal temperament, equal to 261.6 Hertz. Hertz can be classified as cycles per second. Now, how did they get this conclusion? It's complicated. Now, in harmonics, there are usually fractions related to it. You have a half note being played with just the lowest harmonic. Then there's a third, a fourth, a fifth, a sixth, 2 sevenths, 3 eighths, and 1 ninth. When you combine correct pitch with harmonic and a little creativity, this is what you get.